Within the South Caucasus and our wider region, Armenia's energy sector is highly developed. In terms of its generation mix, it has a balanced, three-part structure, a configuration that is remarkably rare for our region. About one-third of the installed capacity comes from hydropower plants, distributed mainly across Armenia's two main hydro cascades, the Vorotan Cascade and the Sevan Hrazdan Cascade. In addition, our system includes gas-fired thermal power plants, which produce electricity by burning gas, and nuclear energy. This combination places Armenia in a uniquely advantageous strategic position. In recent decades, nuclear capacities have been appearing around Armenia's borders. Turkey is building the Akuyu nuclear power plant, and Iran is building the second reactor of the Bushehr nuclear power plant. Armenia, meanwhile, has had this very same three-component generation mix since 1976, when the first unit of our nuclear power plant was commissioned. In terms of electricity generation and installed capacity, Armenia is a net surplus country. Armenia is fully able to meet its own electricity demand while using its guaranteed capacities to secure substantial exports. With a population of about 3 million, Armenia exports as much electricity as Iran, with its 90 million people, or Turkey, with a population of more than 80 million. Armenia exports significant volumes of electricity, mainly to Iran, and plans have recently been launched to scale up exports toward Georgia as well. This, then, is the second core feature of Armenia's energy system. It stands out as perhaps the only net surplus country in the region able to export electricity. Moreover, by carrying out specific strategic projects, Armenia has the potential to double its export capacity while fully preserving its domestic energy security. The third defining feature of Armenia's energy system is the rapid, unprecedented expansion of renewable energy, specifically solar photovoltaic power. Today, the installed capacity of solar power is about 2.5 times higher than the generating capacity of our operating nuclear unit. This rapid growth is fundamentally a positive breakthrough. It has triggered a chain of supporting developments, giving rise to entirely new business and service sectors that drive the installation and maintenance of solar systems throughout Armenia. We have a highly valuable commodity to offer Turkey: electricity. Turkey is an energy deficit country, and it will remain so even after the Akuyu nuclear power plant becomes fully operational. A project designed for 4 reactors, with work currently underway on the second. Over the next 7 to 10 years, Turkey, and especially its regions bordering Armenia, will face a persistent electricity deficit. It is therefore in Armenia's strategic interest to reactivate the Gyumri Kars high-voltage transmission line project and to organize electricity exports to Turkey. More broadly, the TRIP program and the related infrastructure development should be seen through the lens of lifting Armenia's comprehensive blockade. If this approach is carried through consistently, restoring the Gyumri Kars high-voltage line will be highly efficient for both countries. It could also pave the way for a higher-class overhead transmission line linking Armenia's nuclear power plant with the Horasan-Erzurum section in Turkey. Operating at a 500 to 750 kilovolt class, such a line would drastically reduce transmission losses. One of the most basic infrastructure pillars for artificial intelligence is the creation of large data centers. These can be thought of as information factories, and their operation demands extremely high quality, exceptionally reliable power supply. In this respect, data centers are divided into distinct tiers. Armenia has reached specific agreements with NVIDIA, a global leader in these technologies, There are plans to set up data centers in Gagarin and Hrazdan using NVIDIA's own technology. These facilities will most likely be classified as Tier 4 data centers. They require a power reliability rate of 99.99%, where voltage and frequency fluctuations must be kept to an absolute minimum, and the phase structure must remain stable. This is a highly complex engineering challenge that few grid systems can meet. While Armenia's three-component energy system has no constraints in terms of volume, targeted measures are needed to maintain quality benchmarks, eliminate voltage fluctuations, and reduce the impact of high harmonics. These problems are entirely solvable. The technical means exist, and building these data centers will open enormous horizons for Armenia on the global IT map. According to long-term projections, Armenia will need 1,200 to 1,300 megawatts of installed, guaranteed nuclear capacity in the 2035 to 2050 time horizon. Recently, official statements have been made about the potential synchronization and parallel operation of the power grids of Armenia and Azerbaijan. In this context, through Georgia-Azerbaijan-Armenia cooperation, the landmark project to export green electricity from the South Caucasus to Europe via a Black Sea subsea cable becomes truly viable precisely through Armenia's participation. Of these three countries, Armenia is the only one with genuine export potential for green energy. Why green? Because in addition to solar energy, under the EU taxonomy rules adopted since 2022, nuclear energy is also classified as a green energy source. This means that Armenia's operating nuclear plant and its future new unit will be recognized as clean energy sources. In the end, it is Armenia that can give this massive regional project real engineering and economic substance. As for the gas for electricity swap and the existing pipeline, Armenia and Iran have for years used only about 30 to 33% of the project's nominal capacity. The original framework provided that Armenia would import roughly 1 billion cubic meters of natural gas a year from Iran, and in return, export around 3 billion kilowatt hours of electricity, a 1-to-3 swap ratio. Unfortunately, over the past years, we have received only about 1/3 of those target volumes, roughly 350 million cubic meters of gas, while exporting around 1 to 1.5 billion kilowatt hours of electricity. Today, our main objective is to scale the Gas for Electricity project up to its nominal design parameters.